Okay, this is the EC4760 breakout VGA game. The main technical content of our project was figuring out how to drive a VGA display with mostly just hardware on the PIC and a small amount of external hardware.
And this PIC is running it at 48 megahertz, right?
Yes.
Yep.
So we have it running using the internal oscillator at 48 megahertz. 50 would be more ideal, but we can't get the internal oscillator to do that. So anyway, what we do is the PIC outputs two separate channels of information. One is SPI, just turning on and off individual pixels.
And is that how you get the high resolution down here?
Yeah. So the what happens there is we can get 1-bit monochrome data out of that at a speed fast enough to turn on and off individual pixels.
24 megahertz.
And so then we wanted to additionally have color though, and so what we do with that is we've set up the DMA to every 16 pixels output a new byte to one of the ports.
And you can see that in the bricks. Each brick is about 16 pixels long.
I see. So those represent the color resolution,
Yep.
effectively.
Yeah.
Okay. And then the single pixel black lines again are the SPI modulation of the color signal.
Right. So SPI is 1 here, and then for this strip it's 0.
And there's an auxiliary board here that ANDs together the DMA channel and the SPI channel before you go to the VGA connector.
So these are just we have two quad AND gates and then a couple of resistor ladders to then generate an analog signal from the digital that we're outputting on the pins. So.
Okay. And did you write a character generator also then?
So we have a font that we downloaded, and basically it's just a lookup table of character and your Y index, and that gives us which of these bytes are set. And so we wrote a little bit of a little bit of logic to render a byte of ones and zeros, and it just does a bunch of bit shifts to figure out which index in the SPI array, because the SPI array buffer is a bunch of ints. So it figures out which index into that to do, and then it bit shifts it to the right location and ORs it.
Okay. So why don't you play it?
Sure.
So you have a little joystick.
Yeah, it's just an analog joystick with a button,
Okay.
which we read through the internal ADC.
Looks like you've been practicing a little bit.
We may have played it a couple of times while testing.
Yeah, we had to iron out a lot of weird bugs.
I believe that because this is all about timing and you need, and for a stable display like this you need something like 100 nanosecond accuracy or maybe a little better.
Yeah, all the rendering and game logic is done in interrupts.
Mm-hmm.
So we're not using proto threads at all.
Right. The threads would be way too slow. And in fact all the rendering is done in the vertical interval, right?
Yeah, so right after the VSync pulse, we do all our game logic, and then after every HSync pulse we try to get all our it's double buffered. So we're rendering the line after us.
Uh-huh.
While we're DMAing one line, we're also rendering the next.
Got it.
But even then, sometimes we would run into issues where rendering would kind of take too much time, and we'd be then rendering into the same line that we were DMAing out.
Every now and then I see the display twitch. Not very often. Do you know what causes that?
We're not exactly sure.
Yeah, so there's some race condition someplace that's
Yeah.
getting you rarely, which means it's almost impossible to debug.
Yeah, my theory might be that one of the interrupts isn't firing as quickly as it needs to on occasion.
Still, very nice. Okay, thanks.